In the vast expanse of our solar system, far beyond the familiar terrestrial planets, lies Uranus, an ice giant shrouded in mystery. Orbiting this distant world is a collection of moons, each with its own story to tell. Among them, Miranda stands out as a true enigma, a celestial puzzle that continues to captivate and intrigue astronomers. Its surface, a chaotic tapestry of towering cliffs, deep canyons, and enigmatic coronae, hints at a past marked by extraordinary geological upheaval. Miranda is a testament to the unpredictable forces that have shaped our solar system, a world of stark beauty and profound scientific value. Miranda's unique appearance, a bizarre combination of seemingly disparate terrains, sets it apart from all other known celestial bodies. It is a world of dramatic contrasts, where smooth plains abruptly give way to sheer cliffs that dwarf even the grandest canyons on Mars. Its very existence challenges our understanding of planetary formation and evolution, prompting us to question the very nature of these celestial wanderers. As we delve deeper into the mysteries of Miranda, we embark on a journey of discovery that promises to reshape our understanding of the solar system and our place within it. The story of Miranda's discovery is one of chance and meticulous observation. On a cold February night in 1948, Gerard Kuiper peered through the McDonald Observatory's telescope. His persistence paid off when he detected a faint point of light near Uranus. This was a previously unknown moon, later named Miranda. The discovery excited the astronomical community. Miranda would reveal itself as one of the most geologically complex moons. Miranda may be small, but it holds big mysteries. It could fit within Texas, measuring just 470 kilometers in diameter. Its gravity molds it into a nearly spherical shape. Miranda boasts a diverse and dramatic landscape, composed mainly of water ice and rock. Typical of outer solar system objects, rock presence suggests a complex formation history. Understanding its interior is key to unraveling its past. Miranda's journey around Uranus is a story of gravitational capture and tidal forces. The moon is tidally locked to its parent planet, always showing the same face to Uranus as it traces its elliptical path. This means that Miranda's day is equal to its orbital period, which is about 1.4 Earth days. As Miranda orbits Uranus, the gravitational pull between the two bodies creates tidal forces that squeeze and stretch the moon's interior. This tidal tug-of-war is not constant. Due to Miranda's slightly elliptical orbit and its tilted axis of rotation, the strength of the tidal forces varies over time. This variation in tidal stress is thought to have played a key role in shaping Miranda's chaotic surface, generating internal heat that powered geological activity in the moon's past. The interplay between orbital dynamics and internal processes is a recurring theme in planetary science. Miranda serves as a striking example of how these forces can combine to sculpt worlds of unexpected complexity. Section 5. A surface like no other: canyons, cliffs and coronae. Miranda's surface is a breathtaking tapestry of contradictions, a chaotic blend of ancient craters, towering cliffs and enigmatic coronae. One of the most striking features is Verona Rupes, a sheer cliff estimated to be over 20 kilometers deep, making it the tallest known cliff in the solar system. This dramatic feature dwarfs even the Grand Canyon and serves as a testament to the immense forces that once ravaged this small moon. Equally captivating are Miranda's coronae, vast oval-shaped regions characterized by concentric rings of ridges and troughs. These unique features, unlike anything else found in the solar system, are thought to be the result of large-scale tectonic activity, perhaps driven by the same tidal forces that heated Miranda's interior. The chaotic juxtaposition of these different terrains, with ancient cratered plains sitting cheek by jowl with younger, more heavily deformed regions, suggests a complex and violent geological history. Section 6. Geological puzzles. Unraveling Miranda's violent past. The very existence of Miranda's chaotic surface presents a profound scientific puzzle. How did such a small, icy world generate enough internal heat to power such dramatic and diverse geological activity? The answer likely lies in a combination of factors. As mentioned earlier, tidal heating, driven by gravitational interactions with Uranus, likely played a significant role. However, some scientists believe that Miranda's unusual appearance could also be the result of a catastrophic impact in its distant past. This impact hypothesis suggests that Miranda was once shattered into pieces by a collision with a large object, perhaps another moon or a stray asteroid. The shattered fragments then reassembled under their own gravity, creating the jumbled patchwork terrain we see today. Whether shaped by tidal forces, giant impacts, or a combination of both, Miranda's surface serves as a testament to the power of nature's forces and a reminder of the dynamic and often violent history of our solar system. Section 7. A frozen world, Miranda's harsh environment. Located at an average distance of 130,000 kilometers from Uranus, Miranda exists in a realm of perpetual twilight and frigid temperatures. With an average surface temperature estimated to be around -187 degrees Celsius, it is one of the coldest places in the solar system. Its thin, tenuous atmosphere, if it can even be called that, is composed mainly of nitrogen and methane, offering little protection from the harsh realities of space. Furthermore, Miranda lies within Uranus's magnetosphere, a region of space dominated by the planet's magnetic field. This exposes the Moon to a constant bombardment of charged particles from the solar wind, which can interact with its icy surface and potentially contribute to the formation of its unique surface features. Understanding the interplay between Miranda's surface, its tenuous atmosphere, and the surrounding magnetospheric environment is crucial to painting a complete picture of this enigmatic world. Section 8. A fleeting glance, Voyager 2 and future exploration. Our current understanding of Miranda is based largely on observations made by NASA's Voyager 2 spacecraft, which flew past the Uranian system in January 1986. During its brief encounter, Voyager 2 captured the first detailed images of Miranda's surface, revealing its chaotic and unexpected beauty. These images revolutionized our understanding of this distant moon, transforming it from a faint point of light into a world of astonishing geological complexity. However, Voyager 2's flyby was just that, a fleeting glance. Many questions about Miranda's composition, internal structure, and geological history remain unanswered. To truly unlock Miranda's secrets, a dedicated mission to the Uranian system is needed. Such a mission could include an orbiter that could study Miranda in detail over an extended period, mapping its surface, probing its interior, and analyzing its tenuous atmosphere. With the right instruments and a bit of luck, a future mission to Miranda could revolutionize our understanding of this enigmatic world and its place in the grand tapestry of the solar system. Section 9. Mysteries and marvels, unanswered questions and intriguing facts. Despite the wealth of information gleaned from Voyager 2's flyby, Miranda remains one of the most enigmatic objects in our solar system. Its unique surface features continue to spark debate and inspire new theories about its formation and evolution. One of the biggest mysteries is the origin of Miranda's coronae. While the prevailing theory suggests they are linked to upwelling of warmer ice from the Moon's interior, the exact mechanisms involved are still poorly understood. Another intriguing question is the role of impacts in shaping Miranda's surface. While some scientists believe a catastrophic impact may have been responsible for its jumbled appearance, others argue that tidal forces alone can explain the observed features. The lack of a substantial atmosphere and the presence of extremely old surfaces, alongside much younger ones, further complicate the picture, raising questions about the timing and nature of geological processes on this distant world. Miranda is a treasure trove of unanswered questions, each one a tantalizing clue to the secrets it holds. Section 10. Unlocking Miranda's secrets, a window into the solar system's past. Miranda, despite its small size and distant location, holds immense scientific value. By studying this enigmatic moon, we can gain insights into the processes that shape the outer solar system and the diverse array of worlds that reside there. Its chaotic surface serves as a record of past geological activity, while its icy composition provides clues about the conditions that existed during the early solar system's formation. Furthermore, Miranda's unique characteristics make it an ideal natural laboratory for studying the effects of tidal forces on planetary bodies. Understanding these forces is crucial to understanding the evolution of planetary systems, both in our own solar system and beyond. Miranda, with its bizarre beauty and tantalizing mysteries, beckons us to explore the outer reaches of our cosmic neighborhood. By unraveling its secrets, we can unlock a deeper understanding of our solar system's history and the intricate processes that have shaped the worlds around us.